Thank you, Linda. My name is Barry Radler. As Jim said, I'm a researcher at the Institute on Aging at the University of Wisconsin. And I'm going to be talking to you today. The title of my presentation is a DDI-based data extraction tool for harmonized longitudinal data. That's actually kind of the high point of the presentation. There's going to be a lot of build-up to that point. And then I'm also going to be talking about a lot of problems and challenges that we're facing after demonstrating the tool that we've created. Here is a brief overview of the presentation. I'm going to provide you a lot of background on MIDUS. I think that background is critical for you to understand how we're using DDI and why we came to DDI in the first place. I'll talk about the implementation of our current project goals, how we used different versions and different flavors of DDI. I'll demonstrate the MIDUS Collectica portal. Actually, and this might be technically a little bit challenging, I'll be playing an MP4 of the developer who's going to walk us through this evolving tool. And I'll end up talking about challenges that both MIDUS and DDI are facing. So, to begin with background on MIDUS. MIDUS is an acronym. It stands for Midlife in the United States. It's a national longitudinal study of health and well-being that examines how different factors combine to influence people as they age. It was conceived by a multidisciplinary team of scholars really interested in understanding aging as this integrative process. And MIDUS serves as a really good example of the importance of data management principles in practice. I'm sorry, go ahead. I just want to. So data management principles in general and DDI lifecycle in particular. The reason that is because the characteristics of MIDUS that draw researchers to it, that make it a valuable resource for analysts and researchers, are the same characteristics that tend to pose problems and challenges for data managers. And I think a little bit of background, probably a lot of background of MIDUS is going to make that clear. MIDUS actually began in 1995 at Harvard University with funding from the MacArthur Foundation. The baseline sample consisted of a national sample of over 7,100 individuals with a very wide age range of 25 to 74. Even at baseline, there were some unique characteristics about MIDUS that kind of set it apart. It was a population-level survey, but it also included one of the largest national samples of twin pairs that have ever been fielded, nearly 1,000 twin pairs. It also included a subsample of siblings of the main RDD respondents. The survey assessments were extensive. They entailed a half-hour phone interview and 2 50-page self-administered questionnaires, so we obtained quite a lot of data from these individuals. And many of these psychological measures, including assessments of personality, positive and negative affect, mental health, that are usually studied in small select sub-studies or small select studies or in individual therapeutic settings, were modified with extensive pre-testing to be administered in a national survey format. The MIDUS baseline also included what we called satellite studies or projects, and these were in-depth inquiries into cognition and daily stress on a subset of individuals who had completed the survey. Using this slide, I'm going to tell the story about the evolution of MIDUS from 1995 to the present. This slide shows the different projects, cohorts, and timelines. Each of the colored bars represents a different data collection project. Within each of those projects is the sample size for that particular project. And the horizontal axis is the data collection timeline. So you can see a baseline, or MIDUS 1, which is what we call it. We have the survey and the 2 projects. The MacArthur funding was really a one-off opportunity. In 2004, a group of the original scholars, intrepid original scholars, obtained NIA funding to turn MIDUS, transform MIDUS into a longitudinal study with about a 9 to 10 year interval between waves. The phone and SAQ instruments were augmented and improved. But really, the most importantly, MIDUS 2 expanded the multidisciplinary focus to include new laboratory assessments of biology and neuroscience, again on subsets of individuals who had completed the survey. Now these additions reinforce MIDUS's conceptualization of aging as this integrated bio-psychosocial process. This is the guiding conceptual framework. I really don't expect you to read the text in each of these, but I think this illustrates that aging is this complex phenomenon, right? It can't be understood by using a singular approach or discipline or methodology. It's complex. So in order to adequately reflect this complexity that exists in reality, this requires a multidisciplinary approach. And the multidisciplinary approach, in turn, requires distinct research protocols entailing distributed data collection over time, and in MIDUS those efforts are shared by different institutions as well. I'm going to briefly run through the entire MIDUS 2 protocol, starting with Project 1, which is the national sample. All respondents have to first participate in the initial sample, which is administered at UW-Madison by the UW Survey Center. This includes the phone and the SAQs that I just mentioned. And Project 1 really is the hub of the enterprise. It's the project around which all these other sub-projects are organized. After completing the phone survey, individuals become eligible for participation in the other projects, which are Project 2, the daily diary study headquartered at Penn State. We use 8 days worth of telephone interviews in which individuals transcribe the daily stress diaries they've been keeping, so we obtain that data. We also actually obtain 4 days worth of salivary cortisol, which is an important stress hormone, so there's biomarker data collection even going on at Project 2. Project 3 is the cognitive assessment. It's headquartered at Brandeis, but actually data collection occurs at UW Survey Center. And Project 4 is pretty much the crowning project. You know, as someone who has a background in survey and marketing research, and I'm used to trying to convince people to give me 15 minutes, 30 minutes of their time, the biomarker project really takes the cake. We actually get individuals to agree to travel to 3 different clinical research units across the country. These are university hospitals, and submit to a 2-day stay, during which we poke and prod them. We run them through a variety of protocols, obtain medical history, tissue samples. There are experimental protocols that are run on them, sleep assessments, which I'll talk about later. So we obtain just an incredible wealth of biomarker data on these individuals. Project 5 is the affective neuroscience project, again at UW-Madison. At UW-Madison because we have a pretty extensive neuroimaging lab. And the affective part of the neuroscience means that it examines how the brain experiences and processes emotion. And we use a variety of technologies, EEG, which is kind of passé at this point actually, MRI and some other emerging technologies, to obtain measures of brain imaging and functioning. So here's the situation at MIDUS 2. We have longitudinal data on the survey and 2 other projects, and baseline information or baseline samples on the laboratory assessments. Now we weren't, this is kind of cheeky of me to say this, we weren't content with this level of complexity. But in all seriousness, there are advantages to be gained by adding samples and cohorts to the MIDUS study. And around the time of MIDUS 2, we did that. We added an African-American sample from the Milwaukee area, you can see that right here, of nearly 600 individuals, in order to really get a better handle on racial health disparities, and to get a better handle on minority experiences of health and well-being. One of the slight dings that the original sample took was that it underrepresented racial minorities. And Milwaukee was chosen largely because of convenience, also because it's one of the most segregated metropolitan areas in the country. It's kind of a unique situation that way, but also because of its, it allowed easy access to the biomarker data collection happening at Madison. A few years later, the MIDUS PI, Dr. Carol Riff, my boss, was provided a merit award by NIA. And we used those funds to obtain a sample of adults from Tokyo, Japan, which we called Midlife in Japan, or MIDJA. And this really opened up, a brand new avenue for research, looking at cross-cultural influences on health and well-being and national influences, et cetera. And only the survey and biomarker assessments were implemented for MIDJA. Since then, we have really taken our foot off the brakes. We continue to grow. We recently completed a longitudinal follow-up of the survey and biomarker projects for MIDJA. And most importantly, we've added 2 new samples, a new national and a new Milwaukee sample, which we call refresher samples. We're doing this ostensibly to refresh the original cohorts. And because we added, because we fielded these samples a few years after the start of the Great Recession, we took advantage of this. We added measures to really gauge the impact of the economic downturn on not only Americans' financial health, but also their physical, mental, and emotional health as well. Further, this situation provided something like a natural experiment. We had 2 national samples and 2 African American samples, one pre and one post recession. And this will allow us to really dial in and parse apart the effects of age cohort and, most importantly, history or period effects. You'll notice that the refresher has followed the same multi-project data collection protocol. And one thing this highlights, I want you to notice the length of these bars in this graph. The data collection field periods for each of these projects is years long. And this is one of the reasons we have such a wide interval in between waves. And even beyond that, within the actual fielding protocol, when an individual completes a project, we have it built into our data management system that they're not allowed to be recontacted for at least 60 days by any other project. So we don't want to risk fatigue effects in our data. We also want to minimize burnout, or just, a lot of people tell us, don't ever call me again. So we're trying to manage that with this situation. Continuing, we most recently completed survey and cognitive data collection on MIDUS 3, or wave 3 of the core sample, and we're hoping and planning on getting funded so we can continue data collection on the other projects as well. So to summarize the current situation, we have 5 samples, 2 national samples, 2 African American samples, and a MIDJA sample, up to 3 waves of data collection. This multidisciplinary design where we have many different types of data capture, and also each of these bars represents a separate data set. The result is a large amount of data, 25,000 variables on over 13,000 individuals distributed across multiple data sets. And finally, because MIDUS is funded by the NIA, we're obligated to share our data. MIDUS has embraced this sharing mandate. It's been very proactive about this. Our data are publicly available at NACDA. Thank you, Jim. And this has resulted in widespread secondary usage of the study. Since 1999, we have over 63,000 downloads, 24,000 unique users across the world. These figures are actually a little stale, Jim. I think they're a few years old, or a few months old. So they're probably quite a bit more than that by now.
Yeah.
The M2 survey data project alone is among the top 10 data downloads of all ICPSR holdings monthly. And the sharing of the data, I know that sometimes there's a lot of resistance to some PIs to sharing data. What I've found, and I think the other MIDUS PIs would agree, is that sharing the data actually has the effect of being data quality control. We have thousands of pairs of eyes basically finding errors and really keeping us honest. So I look at this as, it's not only good that we're sharing this data, but there's a virtuous cycle. And all of these characteristics, these unique characteristics that I'm talking about, especially this last one, the extensive secondary usage of MIDUS, require a robust approach to documentation. When you have a complex set of data sets, you have tens of thousands of secondary users, you want to make your data and your metadata independently understandable and machine actionable. And because of this, MIDUS has made DDI a centerpiece of our documentation system. So I began to explore DDI around 2005, and my motivation was actually quite innocent enough. I was told how they created codebooks at MIDUS 1, and I wanted to avoid that at all, if at all possible. Here's what they look like. It's a human-readable .txt file. These were literally created by hand. I think they tweaked SAS output so that they could provide the descriptive statistics in a columnar format. But the rest of this, they literally typed in, to the point where they were adding spaces manually so that columns would line up. There had to be a better way, right? So from a process standpoint, DDI was already an improvement. It also became quickly apparent that not only was it going to make my life easier from a creation standpoint, but the result was truly interactive and electronic. It wasn't limited to a document that you could print out and put in a binder. This is the MIDUS 1 codebook for just the twin sample. This thing's a few thousand pages long, it weighs a few pounds, and it's kind of limited in what it can do. The final deciding factor, obviously, was that ICPSR, our official archive, was DDI compliant. They could process the XML DDI that we were generating and really exploit its capabilities. So we started with one DDI 2.1 codebook for the M2 survey data. We used the NetStar software, and I hired an XML programmer to help me tweak the resulting XML data, or XML files. And afterwards, we quickly ramped up and created DDI codebooks for nearly all of our publicly available data. And this was the state of our DDI2 codebooks about 6 years ago. And if I can, I'm going to hop in here and demonstrate this. This is what they look like. This is the M2 Project 1 codebook, separated by the phone and SAQ sections. You can download it as HTML, PDF, or XML. Is this one searchable? This one is not searchable. I was hoping to demonstrate that. But here's what the guts of the DDI look like. Nothing really too fantastic. We have variable names, variable labels, question metadata, some descriptive statistics. We kind of shoehorned questionnaire logic into this and skip directions. So we have interactive skip directions so you can follow the flow of the instrument. These are just our local versions. They're housed on the SSC server at UW-Madison. But we do submit PDF codebooks and the DDI XML along with our data and documentation submissions to NACDA and ICPSR. And that's great. It was definitely an improvement, but really the strength of MIDUS lies in its multiple data sets and data types. And this Venn diagram illustrates the nested nature of the MIDUS data. This is somewhat inaccurate, but you get the idea that there's these overlapping data sets. Individuals can be represented in multiple linked data sets. This table shows another perspective. This is a count of all the possible combinations of M2 projects an individual can participate in. So around 2010, I began working with the Collectica software to create DDI codebooks. And soon after, I realized that we could take MIDUS towards a more integrated DDI-based metadata system. First, we upgraded our codebooks from DDI2 to DDI3. And this was critical because for a longitudinal study where the relationships between variables across time is of paramount interest, DDI3 could actually get a handle on that and bring that information into high relief. So we then created a DDI-based Collectica-supported metadata portal using DDI version 3.1. The primary characteristic of the portal, which I'm going to show in just a second, are that metadata and codebooks are all in the same place. They're on one site, and they're searchable within and across codebooks. So this is what the portal looks like. It's a little text heavy, right? But there's an introduction to the study, just very briefly, and what the portal is supposed to do. We have all of our publicly available projects here with 4 links to the right of each of them, and I'm going to walk you through those. Study details provides, these are all DDI elements and fields, by the way. Abstracts, so an introduction to that project, a little bit about methodology, citation information, and importantly, links to the documentation and instruments at NACDA. The browse data is where the DDI codebook really resides. This is the electronic codebook. It's really not too much different from the display that you saw that I just demonstrated with the DDI2 codebooks. We have a few more metadata fields here and descriptive statistics as well. This is searchable, and JART probably won't work. And you can specify the fields that it searches. I think we have this specified to search question text, variable label, and concept. And it's an intelligent search. You can also search across the codebooks. I'm not really thrilled with that functionality on this. This is one of the things that has been on my wish list to improve. The third link, download data, takes you directly to the NACDA download page. This is something Jim and I have been talking about a lot. We don't want to have multiple versions of the same data set floating around. So right now, we point everybody to our official archive, to the authoritative data source at NACDA. The fourth link, download codebook. I used to disparage this, right? A PDF is kind of like old school, low tech. But this is kind of neat because it includes all of the functionality that exists in the portal. It's a few thousand pages long if you want that. But it includes all of the fields. It includes links to all the supporting documentation. And it's a codebook, and this is what that looks like. It retained some of the interactive skip directions as well. This is housed on a Collectica server, but it is available off the MIDUS homepage. So this was our initial attempt at the portal, but as I've demonstrated, MIDUS was growing more complex. We really wanted DDI to do more. And it really wasn't until DDI 3.2 came along that we could really exploit that capability. All that was required was funding. And fortuitously, in 2012, NIA came out with a request for applications that encouraged new approaches to discovery and use of NIA data sets. And my proposal, which was ingeniously titled, was funded in 2013, I'm happy to say. So the significant aims of my proposal were twofold. Using the latest version of DDI, we were going to perform an internal post-hoc harmonization on the survey variables. We wanted to clarify, this is what I've been trying to push DDI to do for a long time, clarify the related nature of longitudinal cross-cohort survey variables. This project was limited to just the survey variables. It's kind of hard for us to wrap our hands around the other types of data, which I'm going to talk about in a little bit. We also wanted to provide a custom data extract that would allow researchers to focus on their variables. We have 25,000 variables. Allowing people to limit that is very helpful. We also wanted to facilitate accurate merges across those multiple data sets. And to talk a little bit about how we accomplish these. The harmonization effort really has relied on something we call a concordance table. It contains a few critical pieces of information. The first is a cross-referenced record of each survey variable and its longitudinal and cross-cohort version. Importantly, we also document in the concordance table differences in question wording or administration or coding or transformations or computations. So if there isn't strict equivalency between versions of a variable, we provide information about that. And I'll show that here in a bit. Here are a few screenshots of what that concordance table looks like. You can see the related variables here at -1, -2, Milwaukee, etc. Also the variable labels so that we can make sense of what we're looking at. And just as importantly as showing where variables are linked, it shows where there are gaps. We document what we call comparability notes when variables aren't strictly equivalent, like I was saying. Take a look. I apologize that it's a little bit small, but take a look at variable A1PA30, for example, which is down here. This variable represents the number of months since the last blood pressure test. And the comparability notes explain why it's not directly comparable with the other variables. It used a different scale. And another piece of information that's kind of critical here is the question of description or concept. And here we've actually assigned a concept to each of the variable. And that way the portal and DDI can search the concept field knowing that it's associated with particular variables. You'll also notice this column here, comparability class. So beyond just describing the differences in detail, we attempted to classify the types of differences based into categories and create this typology. And this screenshot shows the list, the typology we developed based on whether there were enough cases to create a category for this. And this table, I've been really surprised. You know, we're trying to show this tool, and the last few presentations where I've showed this slide, people get real excited. At the European DDI meeting, I'm not sure if it was the UK Data Archive, but they asked if they could use this and share these categories. I think at NADI there was talk about perhaps turning this into a controlled vocabulary, which is all great. And I have to full disclosure, the inspiration for this actually came from a study. It was, I think, the longitudinal survey of immigrants to Canada, which just had some fantastic documentation associated with it. And that's where I got this idea from, which apparently has been very popular. So you can use the concordance table manually. We offer it right now to the MIDUS researchers as a standalone spreadsheet, but it's very large, it's very unwieldy, right? The ideal situation is to bake all this information into the DDI XML code so it lives there so that it's machine readable. And it's also important for the custom data extract in the repository so that researchers have it when they download a data set. So as I think I've made clear, finding emerging variables from across the multiple data sets can be very time consuming. Researchers have to work across data sets. If you're doing biological analysis, you have to obtain important demographic and administration variables from the Project 1 data set, so you have to merge. MIDUS researchers love the idea of a custom data extract, or a CDE. The CDE, as I call it, will allow researchers to use a shopping basket to cherry pick variables from across MIDUS data sets, to create accurately merged, customized data sets limited to the variables of interest, and then also to download those data sets with accompanying customized DDI codebooks. So ultimately, this tool will produce a tighter relationship between the metadata and the data. It will hopefully facilitate cross-fertilization across these disciplines that are represented in MIDUS data sets, and it's going to save researchers time because they can devote more time to analysis and less to massaging, merging, and managing data. So this is usually when I hand it over to Jeremy Iverson, who's one of the principals at Collectica, and he's not here. I tried demoing this myself, but it's very much a work in progress. There's a lot of things that are still moving around, so I asked Jeremy to actually create an MP4, which I am going to try to play now.
I'll start off by searching for some. I can actually search for any type of metadata that's stored in the repository, but in this case, let's say we're interested in taking a look at what variables are available. So the search page lets us search by text. It also lets us search within studies if we're interested in doing that. Right now, I'll just search across all the studies and say I'm interested in finding information about heart, what kind of variables we have about that. So I can search for that. I get a list of variables, and if I'm interested in drilling into any of these, I'll be able to take a look at the details of this variable. And so for any given item that's in the repository, MIDUS has actually marked up quite a bit of information about these. So we have what you'd expect, of course, the name and the label of the variable. We also have the data type, so in this case it's a yes or no question, and we can see the frequency within the data set, how this is distributed. There's also some extra details we can see, so we could actually drill into this code list that represents the data and see that there's some missing values that are possible there as well. And we can also link to some conceptual information. So in this case, we have one of those representative variables, and we'll see how that comes into play in a minute when we take a look at the cross-reference tables. Oftentimes, not in this particular one, but we often have the source question text available here. So that's also available for any variable where that's been marked up. A few things when you're looking at any type of item within Collectica portal here that you'll notice is that on the left we have some extra information, so we can see in which study this variable is used, and we can see the variable groups, which kind of group by topic, so we can see this is a health variable, and we can use this to browse around to different areas of the portal and see what other information there is. So if we want to get the details of the study, we can do that really quickly. We can also flip through this tab here to get some extra information, some revision history for the variable if there is any. In this case, I'm using a test database here, so I don't really have the revision information, but on the live site, there's a lot more of a history there. And importantly, you're able to download this information in different formats. So if I want to download a PDF with just this information for this item, I can do that. And I can also download machine actionable formats for this. So I can download different versions of the data documentation standard, XML for this item, or I can download a JSON representation, which is often used when programming web services and different sorts of things like that. Now let's take a look at the cross-reference tables. So on the left here we have kind of different categories of the variables that appear in the MIDUS data set. And when I select any one of these, like the administrative section, we'll get the different variables that make sense in that section. So we can look at the administrative variables, or we can look at recession variables, or we can look at health variables. And when I select that, I get the list of variables, and then for each data set, I can see which variable name represents that variable within that data set. When a data set doesn't have a variable for this particular row, like physical health at age 16 in this case, we can see that really easily. We can see that we only have this information in MIDUS 1 in this case. But most of the MIDUS data sets have the harmonized variables. So I can also select any of these rows. So looking at self-evaluated health, for example, I can select that and get kind of a quick overview of what that looks like in the different data sets. So we can see.
I'm going to pause Jeremy's demonstration there. He doesn't go into this in detail. This particular function of the tool itself, I think, is really quite something. This is a type of exploratory analysis. In a really quick visual snapshot, you can look across the different cohorts, you can look across the different the waves, and perhaps maybe highlight some interesting or curious data points, or generate hypotheses. I think this has a lot of potential. And I apologize for the softness of the volume. I have it maxed out. Apparently, that's as good as it's going to get. I'll let Jeremy continue.
So we can see the different distributions over time or across the data sets, and I can quickly go through the different variables and take a look at how that looks. So another thing I can do is select different variables that I'd like to keep track of and maybe download later. So I can do that simply by clicking the star there, and it's actually going to select all the variables from the different data sets when I do that. So I could go through and select a few different ones if I'm interested in that, and I can see the count of my basket increasing as I go. Now when I select the basket navigation link, I'm taken to a page that shows me everything that I have added to my basket. It also lets me manage it a little bit. I can create more than one different basket if I want to separate lists out for whatever reason. But here I can see all the variables that I've added to the basket. I've actually added these as those represented variables I've mentioned a couple times, but the portal automatically takes care of adding these real variables that appear in the data sets for me. So I can see I've got 36 in here, which is a much more manageable number than the entire MIDUS data, which is something like 15 or 25,000 variables. I always forget. So I can also then download different ways of looking at this basket. So I could download a PDF, and that's going to be a sort of data dictionary or codebook that I can look at. So if I click that, it's going to just make that in the background for me and send it to download. I could also download the DDI XML, or I can download a CSV of the actual data or an SPSS file containing the actual data. So I'll click that here, and it should send us along a .sav file, which you can open in SPSS. So I could open that up and take a look at that customized data extract. So in the MIDUS example, there are different samples, so that's why some of these variables have all missing values, and here they do not. I could scroll and kind of take a look at how those samples apply to the different variables. Taking a look at the data dictionary, we'll get some kind of nicely formatted description of each variable, including all the extra metadata we have, like the question text and routing instructions that are available in the MIDUS DDI metadata. The administrative section of the site allows appropriately authenticated users to view some statistics about what's inside of Collectica Repository. So in this case on the dashboard, we can see how many registered users there are, how many items are stored in the repository, how many items of the different kinds of types of items are stored. So we have a whole bunch of variable statistics, a lot of category definitions, a lot of variable definitions, and a bunch of other things stored in here. We can see how often these items are accessed. So here we have the most frequently accessed items. It's the different studies are the most often accessed, it looks like. The variables are probably, since there's so many of them, any individual variable is accessed fewer times than the high-level study information. We can see accesses by users. So in the MIDUS case, we're not having people register individual accounts too often. It's just Barry and myself. Most of the access is anonymous, but we can track how often people are viewing things. We can see what people are searching for, and various things like that. There's also a lot of other reporting where you can customize the date ranges and download these reports, and then a lot of site configuration you can do right within this portal here. So that's a quick look at what we've been working on with the new version of Collectica Portal. There is still a bit of work left, but we anticipate a release sometime this summer. Thank you.
So I hope everybody could hear that. As Jeremy said, we're going to continue tweaking and really dialing in the tool for the next few months, and we'll continue to demonstrate this. And that highlights the issue that this is still very much, I'd say, a work in progress. Some of the challenges that lie ahead for us really revolve around the idea that right now, especially the cross-reference tool, is limited to the survey variables. The first, I think the biggest challenge for broadening the use of the tool in MIDUS will be adapting DDI's very survey-centric language and conceptualization to better document the non-survey data captures that we have going on in MIDUS. And these non-survey data captures use very different instruments than a questionnaire. And please indulge me in presenting some visuals of instruments used to collect biomarker and neuroscience data in MIDUS. These not only jazz up the slides with some visuals, but they really emphasize how different these data capture instruments are from a typical survey or questionnaire. These are instruments on the left used in the biomarker clinical exam, and they're very much like those used by your doctor in performing a physical. You have an eye chart reflex hammer, otoscope for ear, nose, and throat, a dynamometer for measuring grip strength, a tuning fork for measuring hearing, a stopwatch for timed walk, a Gulick tape measure, a spirometer for measuring peak flow breathing. And then on the right, I had mentioned that we had done a sleep assessment. This is a sleep watch, and that's somewhat of a misnomer. In fact, 10 years ago, this was cutting edge. Now, you know, there's Acta watches are being sold by Nike, and they measure how many steps you take during the week. But what this the sleep watch did, it was worn by biomarker participants for an entire week. They never took it off. It contains an omnidirectional accelerometer, and it essentially measures the magnitude of physical activity every 30 seconds for a whole week. This is a picture of an individual participating in what we call our psychophysiology experiment. And this is designed to measure how well your body reacts to and recovers from mental or psychological stress. The protocol includes the subject performing computer-administered adaptive math and Stroop tasks, which can be very frustrating, and that builds up stress. You can see that the individual is wearing a phonometer on his finger. This measures beat-to-beat heart rate and blood pressure. He's wearing a respiration band as well. And we collect 5 saliva samples before, during, and after this experiment to measure cortisol levels. And on the right, the lower right, you'll see what are examples of our physical specimen data capture. These tubes include different blood and urine samples from which MIDUS obtains 14 assays from the blood and 6 assays for the urine. I think both of these are being expanded in current proposals. Here the left figure shows an individual in a bone densitometer, which is a flat scan of the body yielding bone density and body composition or percent body fat data. The right figure is an individual inside an MRI tube. The structural MRI data obtains information on the shape and size of the brain, the amygdala, the hippocampus, and other structures. The functional MRI measures change in blood flow in the brain and how the brain reacts to and processes stimuli. And if you notice closely, this individual is staring at a computer screen. It's projecting visual stimuli. The MRI is capturing dynamic data in real time. Neuroscience data, like biomarker data, require adequate description of the data capture. And this is text from the Project 5 documentation that describes how EEG activity was recorded. The raw data points in neuroscience are nearly unintelligible. This text shows the extensive cleaning and massaging that's performed on the EEG variable. And again, please don't read that. It'll make your eyeballs hurt. So there are multiple steps and processes that need to be completed to result in a single variable with a single value for each individual, representing, in this instance, a measure of brain asymmetry or lateralization, shown here from the Project 5 DDI Codebook. And I think what I wanted to show with this is that MIDUS and DDI, I think, are still in a nascent stage in their ability to describe non-survey health data capture and metadata. This neuroimaging variable doesn't use a question. It doesn't require response options or necessarily have skip directions associated with it. We need to find or create appropriate DDI fields that can adequately describe these data captures. And a few years ago, I co-authored a paper at a DDI workshop in Dagstuhl, Germany, that really addressed this issue. And it examined a variety of non-survey data capture contexts and suggested how DDI could capture more information on these data types. And one solution was to use links that point to standalone documentation that includes all of this richness and all this information. And here's a proof of concept. I can't remember who helped me mark this up, but it was someone at ICPSR. This is a proof of concept from a MIDUS 2 Project 1 codebook where we, using the reference field, we actually have hyperlinks to standalone documentation. In this case, a README and the variable naming and coding conventions. But this isn't ideal for a number of reasons. Links can break. In fact, I think these broke soon afterwards because we updated the documentation. It's a bit blunt. The standalone documentation might be hundreds of pages long. The information pertinent to a variable might be buried in it. But most importantly, this information isn't machine readable. All of that metadata in the standalone documentation is not machine readable. A more elegant approach is then to, mark this documentation on data captures and cleaning and transformations in the DDI XML code, baking this information into it so it lives there and it's machine readable. And this latter solution can be accomplished a few different ways. In this paper, we used 3 different DDI elements. But this highlights what I think is a recognized issue in DDI, that there can be many ways to accomplish the same thing. And this breeds complexity and confusion a bit. And partially to address this issue, especially about the lack of clear documentation about how to use the standard to accomplish specific documentation tasks, a new version of DDI is being developed, which Mary can attest to and describe quite well. It's called DDI Lifecycle MD, or Model Driven. And it's, I think, an acknowledgement that partially that DDI should accommodate different data captures. It uses an information model, so it's a model-based approach. And hopefully what's going to come from that is a simplification of the description and the structure of the standard. We're going to avoid XML schemas, which can be very daunting and are perceived entry barriers to using the standard. A side effect of that will be hopefully improved documentation. And a development principle that we've used in trying to develop this next version is that there should only be one way to do one thing. Furthermore, the standard will, with an information model, be expressible in non-XML technologies such as relational databases, RDF, etc. So finally, turning back to the current project involving the MIDUS portal and the harmonized custom data extract. Jim has been extremely supportive of our efforts at exploring DDI and developing these tools, but I think we're at a point now where we really need to better integrate ideally better integrate our local DDI efforts with NACDA and ICPSR's workflows in their infrastructure. We've developed what I think is this pretty useful tool for facilitating complex analysis and clarifying the related nature of related variables. And I want to offer the portal's capabilities to the research public. And once they see this, they're going to want it. But I also have no interest in duplicating the important functions that NACDA and ICPSR have provided MIDUS. We need to maintain official authoritative versions of the MIDUS data, as I've said already. We need to avoid multiple versions. Also, the curation and great job at versioning that NACDA does, we don't want to duplicate that. The download statistics, which have been so helpful, and the fact that you can link them to different data sets, to different publications, those are all useful functions that I have no interest in duplicating. I really see the portal as a value add, it's providing a value added component to NACDA and ICPSR. And so this is really the next critical phase in the MIDUS portal project, how it integrates with NACDA and ICPSR. One simple but I think inadequate solution is simply to link the portal from the NACDA MIDUS page. But unfortunately then there's ripple effects. Portal usage and downloads won't be recorded through ICPSR system. There are some restricted use data sets in the MIDUS data sets that would be freely available through the custom data extract, and we don't want that. And another simple solution, at least this is simple from my perspective, is that ICPSR adopts a DDI-3 tool. And I think not only would this really help, obviously, MIDUS, but the great thing, one of the characteristics about DDI as an open standard, is that all of the development work that, for instance, MIDUS has put into this tool can be freely shared and exploited by other projects as well. So in advocating for a DDI-3 tool at ICPSR, it's not purely self-interest. This could be very beneficial, I think, to the field as well. And with that, I really want to open it up to discussion. I think this is a great opportunity to start that discussion with ICPSR, is how the portal is going to live in conjunction with ICPSR. Yeah, Tom.
So you mentioned that you prefer 2.x to 3.x DDI. What type of process and tool do you use to amplify?
Can you repeat the question?
The question was that MIDUS has transformed or moved along DDI-2 to DDI-3. I think we use Collectica. Collectica, when I first started working with them, they went back and basically recooked the DDI that Nestar had created. So it was a pretty smooth process from transforming from DDI-2 to DDI-3 using the same tool. But I'm also aware of problems with cross-tool compatibility. Even though DDI is a standard, different tools tend to tweak different things, and you might lose metadata from moving from one tool to another tool, or from one version to another version. And I think the more and more that happens, the more and more we're identifying those problems and those gaps and trying to fill them in. Jim.
So after the obvious learning curve of working with these tools, how do you feel about the cost efficiencies in terms of processing from the perspective of somebody who has to take the data from its raw form to a production and distribution quality?
Well, I've experienced that cost-benefit curve, or economies of scale, if you will. There's always that upfront cost. With IT, especially applying IT in social science paradigms and contexts. I've found it incredibly cost efficient, right? I'll come back to answer your question about, what do you say to people that are just coming to DDI, and especially if you're trying to adopt DDI-3, which is the more complex and more kind of imposing standard. What I would say is that people like me and MIDUS and Collectica have already kind of done some advanced work. So in a sense, we've kind of cleared a path, and I'm working with the Vietnam era of twin study of aging, and Carol Franz there, who's the PI or one of the PIs for that, she's benefiting by working with us and learning what we've done. So her entry barriers to DDI-3 are lower. Same thing with WLS, the Wisconsin longitudinal system. They've been interested in DDI-2 for a long time. They're going to be able to benefit directly from the work that we've already done.
It sounds like a lot of the benefit would be for longitudinal studies, or repeated cross sections? What about studies that are just cross sections one at a time? Would there be benefits to putting that into DDI?
I think so, and I've talked with Mary. The question was DDI3 especially is germane to and appropriate for complex studies and maybe repeated cross-sectional and longitudinal studies. My own personal philosophy is that if you're just doing a one-off study or one-off project, DDI2 is probably fine. What the benefit, the advantage of DDI3 is that linked data. So if you do have repeated cross-sectional studies and you want to highlight those links, you want to highlight where variables have some meaningful relationship, then I would recommend DDI3.
Well, think about Mary real quick. If you could mention the website where the MIDUS metadata and all your documentation is located, because that's an excellent website. In addition to what's at NACDA, that's where the real details are.
I'll bring it up at the end, but it's midus.wisc.edu, I think. And the portal is, there's a link off of the MIDUS homepage. It should be pretty easy to find.
I'm sorry,
George.
So we've been working in this direction too, and I'm looking forward to this afternoon to demonstrating to the crosswalk that we've made for GSS.
Great.
Yes, which has a lot of the same features, and as you know, the ICPSR website does variable level searches.
Yep.
and comparisons.
And downloads as well.
But what I was really interested in was your experience from the harmonization, and I was impressed by this categorization of that you showed of how the variables had to be harmonized. How much of that have you been able, of that harmonization work, have you been able to capture in the DDI? And is that an area where, is DDI sufficient now, or is that an area where DDI should be expanded?
So for the web audience, George had a question about the comparability and equivalency information and if DDI is sufficient to capture that right now. One thing that Jeremy's demo didn't show, because it's not there yet, is those comparability notes in comparability class. There's not, Mary, correct me if I'm wrong, but I don't know if there's a home for that information in the schema right now. There is. Okay. So apparently there is a home for it. I think that I'm not a technical expert at DDI, and that's one thing that does overwhelm me sometimes. Is there's 800 or 900 different tags and fields, and sometimes there might be something out there that I don't even know exists or how to use it. So apparently Mary answered that yes, there is a comparability field. Sanda.
Yes, there is a place where you can actually, and we have developed a control vocabulary for it as well. That's why medicine, I was interested in like talking to him to see how maybe we can come up with a common vocabulary that can be incorporated in DDI.
This might be a nice thing for a side meeting at ISS.
So Sanda mentioned that she's interested in creating the controlled vocabulary. We talked about this at the NADI conference a little bit. You mentioned it.
Yeah, there is a vocabulary right now. It's pretty simplistic. It has 3 terms for degree of comparability, whereas you seem to have about 15.
Yeah.
So that's why I want to look at them maybe together with you and see how we can maybe come to a common denominator.
That sounds great.
Then everybody could use it. It would be totally shareable. Okay.
Mary?
So related to that, how did you come up with the concepts that you're using on that, in that crosswalk or concordance?
I don't think there's a great answer. The question was, how do we come up with the concepts that we assign to each of the variables? We kept it at a very kind of superficial level. We really didn't go into too much detail. It was kind of an expansion on the section topic. I don't know if you recall. We have all these different sections, so they're broadly variables and measures are grouped into broad categories. And we just tried to, without really getting buried in the weeds, add a little bit more description to the concept. Yeah.
Can you talk about how the raw data are stored in the Stellar repository and how you do the extracts into the multiple formats?
Right. The question is, can I say anything about how the raw data are stored on the Collectica repository? And the short answer is no, because I'm not sure. This is actually also one of the things that we're in uncharted territory with. We've never actually, Collectica and I have never actually had to account for the data sets themselves. So I don't know in what format or system those are in right now. But I'm assuming they're in something that's relatively malleable, since we can download it as CSV and SPSS and data. I wish I could have a better response to that, but Jeremy and Dan would be able to tell you. Do you have a follow-up? Go ahead.
Yeah. So when you capture the data, where is that stored for your project?
When we actually do the data capture, the UW Survey Center uses the cases software.
Okay.
And so they capture it with the cases software and spit it out into SPSS.
Okay.
And unfortunately, we've been saddled with a legacy of using SPSS. The one thing I'll say in defense of SPSS is it seems to be relatively metadata friendly compared to like SAS or R, for instance. Since you brought up the actual data capture situation, we're also lucky because cases is somewhat DDI compliant too. I think their SDA and cases, right, are the same.
Yeah, they're part of the same family.
They're part of the same family. So that has made metadata capture for the survey portion of it quite easy, because we can just grab all the fields that we want from the CAI software.
Okay, so you dump out the metadata from the software, and do you do enhancement in a separate system of that metadata? Do you pull it into the collective repository to enhance it there, or do you use NASDAR or a raw XML?
We haven't used NASDAR. We got away from NASDAR because it's DDI2 compliant, and they don't seem to have any plans to upgrade to DDI3. To answer your question, we have a pretty simple, slick system right now, where once I have a clean SPSS data set that I've run through all my procedures, we also have a separate, what we call a metadata spreadsheet. So anything that's not already in the SPSS data set, like question text and all the other fields that the CAI software spits out, we append those into a spreadsheet, and then it is merged with the Collectica XML. So we just essentially create the DDI from two data sources: all of the metadata that's contained in the SPSS data file, and a separate spreadsheet that contains anything else that we want to add.
You said you can merge the data sets for an extract?
Yeah.
Is that because the DDI3?
Not necessarily. I think you saw that we were just kind of stacking the data sets on top of each other. The nice thing just about an automated merge is that it's saving some headache for people that might not be well versed in merging.
And can you merge at different levels of analysis, or is it all the same level of analysis?
At this point, it's just at the same level. I think we have some long data sets versus wide data sets that are stacked, if you will. Those, I think, that's one of the wrinkles we have yet to iron out. That's a great question. Those are the things that are we're trying to really iron out as we try to finish up this project.
Great. Well, I think we're just about out of time. So.
Just put the website up.
Yeah, I just want to finish by acknowledging generous research support that's made not only the DDI projects, but MIDUS as well, possible. And thank you very much. There is the MIDUS website. You can find the Collectica portal. On that website, the current tool with the CDE isn't live yet, but hopefully this summer. Thank you.